Everyone, I am Shilpa Singh from Jamshedpur. Today's topic is all about basics of gear and gear systems. Let's start with understanding the concept of drive. The arrangement made for transmitting motion and power from prime mover to machine or from one shaft to other is called drive. The various types of drives are belt drive, chain drive, rope drive, friction drive, gear drive, cam drive, crank drive, hydraulic drive, etc. When to go for gear drive? The selection of a particular type of drive depends mostly upon the power requirement and the distance between the driving shafts. The slipping of a belt or rope is a common phenomena in the transmission of motion or power between two shafts. The effect of slipping is to reduce the velocity ratio of the system. In precision machines, in which a definite velocity ratio is important, as in watch mechanism, the only positive drive is by gears or two wheels. A gear drive is also provided when the distance between the driver and the follower is very small. When torque conversion is required, devices other than gears must be considered, especially when a variable ratio is desirable, but for a synchronized drive with high torsional stiffness, gears are ideal. What gear drives are? Gears are the mechanical device to transmit motion and power from one shaft to other shaft through toothed wheels. Gear drive has replaced the friction drive to prevent slip, and the gear drive gives constant transmission ratio, hence called positive drive. It can transmit large amount of power. Now let's learn about the advantages and limitations of gear drive. Advantages: it has too many points. First, it is a positive drive where velocity ratio remains constant. Second, it is compact in construction due to small center distance between shafts. Third, it can transmit large power because of strong material. Fourth, efficiency is very high, 99% in case of spur gear. Fifth, wide range of speed changing is possible by shifting of gear. Sixth, it can withstand a high temperature. 7. It is applicable in rotary and reciprocating motion both. Last, it can transmit power with different orientations of shafts. Now let's learn about its limitations. Its initial cost is high. Manufacturing of gears are tough. It is used for short distance shaft access. It gets damaged instantaneously in case of lubrication failure. Installation and maintenance are difficult. It needs careful attention of lubrication and cleanliness. Reconditioning is normally not possible. If not installed properly, can damage bearing, shaft, housing, seals, etc. Gears are mainly classified according to the mutual position of the shafts and the position of meshing. So, let's go for its classification. Basis mutual position of the shafts, gears are divided into three categories: parallel shafts, intersecting shafts, and non-parallel, non-intersecting shafts. According to the position of meshing, gears are of two types: external meshing and internal meshing. In this session, our focus is on gears classified basis mutual position of shafts only. Based on position of meshing, you can see the enlarged figure in which everything is mentioned: worm wheel, worm, internal gear, gear coupling, miter gear, helical gear, spur gear, spiral bevel gear, straight bevel gear, involute spline shafts and bushings, rack, pawl, pinion, ratchet, screw gear, etc. Now let's learn about gears classification based on parallel shafts. They are spur gears, single helical gears, and many more, which I have already mentioned above. So let's study it in detail. Spur gears. It has straight teeth parallel to the axis of rotation, used to transmit power in parallel shafts. Second, it transmits moderate amount of power. While transmitting power, it generates lots of noise. Third, it may be internal or external. Fourth, it imposes only radial load on the bearing. Let's learn about single helical gears. First, in helical gear, teeth are out at an angle with the axis of shaft. Second, The magnitude of helix angle of two mating gears is same but the hand of helix is opposite. Third, a right hand pinion meshes with a left hand gear and vice versa. Fourth, helical gear impose radial and thrust loads on shafts. Fifth, it has greater load carrying capacity. Let's go for double helical gears. A double helical gear is equivalent to a pair of helical gears secured together, one having right hand helix and the other a left hand helix. Axial thrust, which occurs in case of single helical gears, is eliminated in double helical gears. This is because the axial thrust of two rows of teeth cancel each other out. These can be run at high speed with less noise and vibration. Now let's learn about herringbone gear in double helical gear itself. If the left and right inclinations of a double helical gear meet at a common apex and there is no groove in between the gear is known as herringbone gear. Manufacturing of this gear is difficult as there is no tool clearance between two helix of gears. Last but not the least, rack and pinion. Rack, a segment of a spur gear having infinite diameter. Pinion, a small spur gear. This arrangement converts rotary motion to reciprocating motion and vice versa. Now here we go, gears classification based on intersecting shafts. In this we will learn about straight tooth bevel gears, spiral bevel gears and many more. Let's learn about straight tooth bevel gears. The shape of bevel gear have a truncated cone. The teeth are straight, radial to point of intersection of shaft axis and vary in cross section throughout their length. Usually they are used to connect shafts at right angles but also can be slightly more or less than 90 degrees. Bevel gears impose radial and thrust load on shaft. Spiral bevel gears. When the teeth of a bevel gear are inclined at an angle to the face of the bevel or helical bevel gears. They are smoother in action and quieter in operation than straight bevel gear, mostly used in differential gearbox of automobile. Spiral bevel gears are of two types, zero bevel gear, miter bevel gear. Zero bevel gear. Spiral bevel gear with curved teeth with a 0-degree spiral angle are known as zero bevel gears. Miter bevel gear. Miter gears are bevel gears with a speed ratio of 1. They are used to change the direction of power transmission without changing speed. There are straight miter and spiral miter gears. When using the spiral miter gears, it becomes necessary to consider using thrust bearings since they produce thrust force in the axial direction. Besides the usual miter gears with 90-degree shaft angles, miter gears with any other shaft angles are called angular miter gears. Let's learn about gears classification based on non-parallel, non-intersecting shafts, in which we have worm and worm wheel, spiral gears and many more. Let's learn about worm and worm wheel gears. Worm and worm wheel gears. The worm is form of a threaded screw which meshed with the mating wheel known as worm wheel. The threads on worm can be single or multi-start and usually have a small lead. It is used to transmit power in non-parallel and non-intersecting shafts for high reduction ratio. It may be irreversible also. There is sliding contact between worm and worm wheel teeth and worm is always driving member. Spiral gears. Spiral gears are also called as crossed helical gears, used for power transmission in non-parallel, non-intersecting shafts for lighter load. By selecting suitable helix angle for mating gears, the two shafts can be set at any desired angle. Last but not the least, hypoid gears. Hypoid gears are a variant of spiral bevel gears in which the axis of the pinion is offset from the axis of the wheel. The result is an increase in pinion diameter for given wheel diameter and ratio, possibility to use bearings in both ends of the pinion. So here I would like to end my session. Hope so you gained something with this session. Session appointment is available via mail at shilpisingh170@gmail.com or through your YouTube comment section. So, guys, don't forget to like, share, and subscribe for more updates. Next session coming soon. Thanks for your patience.